The year is 1890. The Eiffel Tower has just been built. Yellowstone has become the first national park. Ellis Island has opened its doors to a flood of immigrants entering the United States. And Samuel Pierpont Langley, third Secretary of the Smithsonian, has lobbied Congress to appropriate $10,000 to build the Smithsonian Astrophysical Observatory, thus implementing former President John Quincy Adams' dream of creating a lighthouse of the skies. Engineer, aeronautics pioneer, inventor, and astronomer, Samuel Pierpont Langley sees that the main mission of the Smithsonian Astrophysical Observatory is to unlock the secrets of the sun and the universe, leading to the diffusion of knowledge. For the next 60 years, from observatory stations in Sumatra, Chile, Egypt, and Southwest Africa, his dream is actively pursued. In 1955, the observatory moves to Cambridge, Massachusetts, and continues its growth when in 1973 it joins with the Harvard College Observatory under a single director to become the Harvard-Smithsonian Center for Astrophysics. Today, more than 300 Smithsonian and Harvard scientists are engaged in astrophysical research, earth and space sciences, and science education. In the past 3 decades, these scientists have made some of the greatest discoveries in astrophysics. The great walls of galaxies that outline the structure of the universe. Some of the farthest new planets orbiting distant stars. And that the expansion of the universe seems to be speeding up. From the beginning of time, humans have pondered, how did it all begin? Where did the universe and everything we see around us come from? On a mountaintop in southern Arizona, the University of Arizona and Smithsonian's 6.5-meter MMT telescope prepares to search for clues to the origins of galaxies and the accelerating universe. Probing millions of light years away, the MMT is a time machine, recording the faint light that has traveled through space for millions of years, reconstructing a universe as it existed in another time. Meanwhile, in Hawaii, atop the largest volcano on Earth, Smithsonian's sub-millimeter array surveys the skies, identifying the basic molecular building blocks of the early universe. It is seeking clues on how our infant universe came into being and what it is made of. And in Chile, located high atop the Andes, astronomers use the Magellan telescope to search for ancient supernovae, giant stars that have exploded, to try to determine how fast the expansion of the universe is speeding up since the Big Bang. Continuing in Langley's footsteps, the Smithsonian is studying the sun's corona using the X-ray telescope on the Anode mission, built by the Smithsonian in collaboration with Japanese scientists. The telescope captures the evolution of active regions on the sun that sometimes erupt, releasing huge amounts of energy in solar flares and coronal mass ejections. And thousands of miles above the Earth, the NASA Chandra X-ray Observatory, operated by the Smithsonian, studies some of the most energetic and violent events taking place in the universe. Here, Chandra captures the heart of the Milky Way galaxy, revealing the telltale signs of a giant black hole. And here, we see the remnants of a star that exploded hundreds of years ago. Sometimes in science, the simplest questions are the hardest to answer. For instance, how do planets form? In Smithsonian laboratories, scientists create computer models tracing the formation of early planetary systems, trying to determine just how they came together. Meanwhile, a team of Smithsonian scientists, using NASA's Spitzer Space Telescope, maps the universe with infrared cameras. Invisible to the naked eye, the infrared universe is filled with dust, the raw material for the formation of new stars and planets. With all this new information flooding in, one big question still remains unanswered. Are we alone? As surprising as it may seem, the answer to this question may be known much sooner than most people realize. In orbit around the Earth, Smithsonian scientists are using the Kepler spacecraft to search for Earth-like planets orbiting distant stars. So far, more than 2,000 new planets have been identified, but ones resembling Earth still remain hidden from view. To assist in this grand discovery, a new wave of giant ground-based telescopes has begun. Today, a new mirror emerges from the casting ovens at the University of Arizona Mirror Labs. It is one of 7 mirrors that will constitute a giant new telescope in which the Smithsonian will be a major player. When completed, it will dwarf any telescope ever made before. It is called the Giant Magellan Telescope, or GMT, and will be located in Chile. The GMT will have 10 times the resolution, or seeing power, of the Hubble Space Telescope, and will search for extrasolar planets, black holes, dark matter, and the first stars and galaxies that formed after the Big Bang. As Smithsonian astronomers look ahead, the shoreline of discovery extends further than any can see. One wonders what Samuel Pierpont Langley might think today if he could see how the fledgling observatory in the backyard of the Smithsonian Castle has grown to become one of the world's foremost astrophysical research institutions. From mountaintop observatories to cutting-edge laboratories and orbiting space telescopes, Smithsonian astronomers cover the entire spectrum from radio waves to gamma rays. They are proudly carrying the dream of a lighthouse of the skies into the 21st century and beyond.